Joan was telling me about this. You put the Guinness inside the chicken and cook it like this in the oven. And then the Guinness comes up into the chicken. It's delicious.
Is it healthy?
Oh, not that bad.
You can take the Guinness.
But when you eating the chicken, you want to you should eat more.
Your homestay brother made it?
Yeah.
How old is he?
20.
Okay.
Very young.
Is it? Guinness chicken. You still have some at home? Oh, you have some with you. Oh, nice. Nice. Okay.
Today morning I saw you are running to the school. I thought, oh, Stephen is
Today?
late and he is running to the classroom and you are running to the office.
Yes. That is true. That is true.
I should have my coffee.
I was wondering if you'd go to Starbucks, and I was thinking.
Because I saw you are running.
Yes.
If you're not running, I want to get coffee. But you are running.
I was running to get coffee.
Yeah.
Yes. Okay.
Next time I will get coffee.
Yeah. Okay. Do you have Excel open, Hareen?
Yeah.
No, it's not open.
Okay. Well, I'll just draw a picture while you're waiting.
You play World of Warcraft?
Oh no. No. I should show you the games I play later. Okay. So, huh? No. This is not for games. Yes. Now, you know, have you got Excel open? Yeah. You know that sometimes, for example, we need to use the slope to calculate. For example, do you remember with the experiment with the Ohm's law, the circuit? Here, let me just think what goes on the x-axis. It was V here, and the I here. Yeah. And you make a line here, and if you remember, you have the formula V equals I or, so I equals 1 over or V. So what does the slope here equal of this line? 1 over or. So then the or is 1 over the slope. This is just a reminder. You remember this, don't you? Yeah. Can I go back to the side? Yes? So going back to the side. But you understand that if you calculate the m here, is it perfect? No, there'll be an uncertainty, because maybe next time you do it, your points will be a little different and your line will be a little different. So what we want to look at today is how to calculate the uncertainty in the slope. That's what we're going to learn now. Yeah? So firstly, do you understand what we're trying to figure out? No. You understand that this is not perfect because the line can move a little? So we want to calculate the error in the slope. So for example here, the slope, maybe the slope equals 2, and we want to know the plus minus part. Yeah? Okay. So let's calculate. So let's make up some data. We'll have 10 points. We'll call them X. We'll call it Y. So I'll go with, I don't know, 1, 2.1, 3.05, 3.99, 4.95, 6, 7.1, 8.01, 8.89, 10, something like this. Okay, and let's put in some y values. Don't write these down just yet, I need to fix them. Okay, so if you want to type these values in so it can be the same, here's our x and here's our y. You have your laptop? Yeah. Tell me when you're ready. You have these? Irene? You have these? Are you checking Facebook? Is that the technical difficulty?
The numbers, like I'm adding up, like there's one extra. And then zero and on. I see it.
Great. Can I continue?
No.
Well, I'll continue, but I'll try and just put it to the right here. So if I insert the chart, now I don't need you to do the graph part yet, so I just want to show you the graph, but I don't actually need it. So I just want to show you it. No, not this graph. Scatter. Graph. X in X units. And then Y in Y units. Now I'll delete this in a moment, but I just want to show you it. So you can't quite see, but you can see that the points, they don't perfectly match the line, because for example, you see this point is a little bit off the line, and I need to zoom in, but if you look closely, the points aren't actually perfectly on the line. But the graph is not what I really want to talk about today, so I'll delete that if I can. So what I want to calculate is the equation of this line. So this line will be y equals mx plus c. So how do we calculate the m and how do we calculate the c? You can do this easily in Excel. Let me show you. So if you want to calculate the slope m and the intercept c, you use this function. It's called slope. So you type equals slope. Can you see that? Yeah, and then bracket, and then you pick the y's, comma, and then you pick the x. Close. I'll do it again. Watch, then type. No, watch, then type. Equals slope, bracket, highlight y, comma, highlight x, bracket. So it's like this. This is the slope. One more time. Do I need to make the font bigger, is it? Too big. Too big. Okay. Equals slope bracket 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 bracket. Yes? Equals slope bracket y's comma x's bracket. Oh my goodness, what's wrong? Did you get this, Erin? Sophie? One more time. Slope bracket y's comma x's bracket. Did you get 1.99?
Yeah.
Did you get? Oh my goodness. You spelled slope wrong. S-L-O-P-E. Yeah. No, you said S-L-P-O-E. Yeah. No. Watch. Equals slope bracket y comma x's close. Your answer is different, but that's okay. You typed something wrong, but that's not important. Did you get this, Sophie? Yep. Can I continue, Javier?
Yeah.
So, what do you think the formula is for intercept?
Y2.
No. Equals intercept bracket y's comma x's. The same. Except the only difference is you use the word intercept instead of slope. That's all. Except intercept instead of slope. I-N-T-E-R-C-E-P-T.
Change slope
To intercept. Yeah? Are you making notes, Andy? Yeah. This is really important for the type lab report 3 and 4. The typed one. Okay, can I continue yet?
No.
Continue. Yeah, okay. So, if you go now back to my picture, what have we calculated so far? We know what the slope is. I think I said 1.99x. And what's the intercept?
1.04.
Plus 1.04. You got that? Yeah? So what is the slope here? 1.99. Okay. Now, the next calculation is called y hat.
Does it have to be capital?
No. So let me explain what y hat is. If you look here, you see this number here, for example, oh my goodness, here, this is x. If this is x and I go up to the line, then go across, this is what I think the y should be. But if you look at my data, you can see the y is here. Is it the same? No, it's a little different. Here's another example. Here is x. So if I go up and across, this is what I think the y should be, but you can see that it's not quite the same number. It's a little bit different because the points are not on the line. No, Grace, you look so unhappy. One, two, three, four, line. Okay, let's say this here is 1 and this here is 1. So if I'm here, I think the y should be this number. Is it this number? No, because here's my data, the y is up here. It's bigger than what I thought if I use the line. This is because the points are not on the line. If the point was on the line, then I'm happy because here's my x and then here's my y and they're the same height. Yeah. So the y hat is what I think the y should be. Any ideas on how I could calculate that?
So the y hat is not the actual.
It's not the actual value of y? No, it's what I think the y should have been. Yeah.
Basically it's the dot, right?
Basically the y hat is the value you get by using the line for x. So does anyone have any ideas on how I could calculate y hat? Y hat is on the line. So how can I calculate it if I know the x?
So like swallow it into the linear.
Yeah, just put it into the linear. If you put x into the formula, it gives you the y. It won't be the true y, it'll be the y on the line. You get the idea? Okay. So can I go back to the spreadsheet? Yeah. This? Right. So, equals, where is my m? Here it is, yeah, here it is here. So it's m multiplied by x plus c. Should I get a number that's nearly 3.01? Yeah, I should. Will it be exactly 3.01? No. See? It's nearly 3.01. Oh, hurry in. Watch. Equals m times x plus c. Intercept here. Hat. Okay. Have you done that for the first one? Grace? Yeah. Now, if you want to do it for all of them, there's a little trick. Please watch carefully. If I click this box, the B14 is for the M and the B15 is for the C. And these are constants. We don't want them to change. So what you do in Excel is you put a $ in front of the B and the 14, and you put a dollar sign in front of the B and the 15. So there's a dollar sign in front of B14 and B15. It shouldn't change the number.
Why is mine B13?
Because maybe you didn't write XY on the top, or maybe you don't have two lines between the data and the slope and intercept.
That's the same, right?
Yeah. Have you done that?
You should put dollar sign only in those.
Only on the N and the C part, the constant. Have you done that? Yeah? Can I show you the next part? So then what you can do is a trick. If you grab the corner, there. If you grab the corner and pull it down. Yeah, watch, look. See, it changes. And you can grab and pull it down. And these are all the Y hats. Do you have something similar? Do you have the same numbers nearly? No? Yes. How to do this? Yeah. Okay, now, the next part. Next, now what we want to do is the opposite. So, for example, if we know the Y, we want to go across to the line and down to get the X hat. Do you understand? Yeah? So, if you think about your formula, we have Y equals mx plus c. You can change that into Y minus c over m equals x. So if you put your Y into the formula here, you can get your X hat. You're just going the other way. Yeah? Yeah? The dollar sign is just missing on the 14 as well. So if we put a dollar sign here, now I think it should be okay. Yeah. $2 signs. Oh yeah, you're missing it here as well actually. Okay, continue. Yes? So now we'll have a column called X hat. So if you look back here, this will be Y minus C over M. Y minus C over M. So equals, are you watching? Watching, Grace? Watching? Equals bracket Y minus C bracket over M. And you see, look, how it's nearly the same as 1, but not the same. Now, don't forget, we have to put the dollar sign on the C, which is B15, so dollar sign, and put it on the B14, which is the M, dollar sign, like the last one. Okay, now try to do that yourself. Yeah? So if I copy it down, I get this. Ah.
Dollar sign on 15.
Yeah, dollar sign on the B15 and B14, like in the last example. Yep. The dollar sign tells Excel that this is a constant, not to change its value. Okay, can I go back to my picture? So, look here, look. So you see here, this is X, and what would this be? This is Y hat, and this one here would be the true Y. So this difference here is like an error. We have a name for that. We call this the residual. Residual. It's the difference between what we have in the data and what we have from the equation. No, they're not, sorry. Thank you, Sophie. That's just Y. And likewise here, here if I go across, this one here is the X hat, and this one here is the X. So you also have a residual here as well, the difference between the X. Should the residual be big or small?
Small.
Should be small.
Wow.
Because you want the point to be near the line, not away from the line. Yeah? Can I go back to Excel? Right, how can I calculate the residual? Well, it's just going to be Y minus Y hat and X minus X hat with positives only. So here, type in equals ABS bracket Y minus Y hat close bracket. We'll call this residual Y, and this one residual X, equals ABS bracket X minus X hat close. Yeah, with ABS. Great, ABS means this, make positive. Have you done that part? So we'll copy this down, all the way down, and then copy this all the way down. So what I'll have here is average residual. So here I'll just type in equals average bracket all the y's, close bracket. And here I'll type in equals average bracket all the x's, close bracket.
How did you get the average if you do?
Just use function is called average, see? It's just called average, the function.
What's the point of bracketing in the y?
Yeah, the y's and then one for the x's. Yeah, watch. Equals average bracket the y's, close bracket. Watch again. Average bracket x's, close bracket. Yeah, I want, can you see here, average, all of this. Average, bracket, and then I highlight. Equals, average, bracket, highlight, close. Have you got this? Sylvie, do you have this? Yeah. And Hareen? Yeah. Grace? 1 minute. Amanda?
So can you upload the video?
Oh yes, I'm recording this. Yeah. I'll call the lesson something like calculating uncertainty in Excel. Okay, can I?
No.
Oh, please. I have Fahad and Karar and Yemi next. I need a break before them. I'm only going to give you 10 more seconds. Okay, I have to continue now. So, we know the reason we do all of this calculation is to use this formula. If you want the uncertainty in the slope, the formula is the average residual for the y's divided by the average residual for the x's. You know what? I use the letter or, but I think a lot of people use the letter E for error. It doesn't matter. Or I'll write in, I know what I'll do, I'll write in average residual for the y's divided by average residual for the x's all over square root n, where n is how many points you have. It's the number of points. Okay, can I go back to Excel now? Yeah, so in this example there was 10. Can I go back? So, here, I would have delta m, that would equal bracket this number divided by this number, bracket, divided by, how many numbers do I have? How many rows? 10. 10 actually, starts at 2. So divided by square root, SQRT, square root 10. The two averages. This one divided by this one. square root.
Square root 10.
Square root 10. Square root. Because there are 10 rows. 10. Okay? Can I press enter? Point 62. Bigger than I thought. Actually, I think. Hang on, let me think. Wait, I need to show you something else, but I just want to have a quick check. Maybe I got something wrong though. Do you have the internet open, Sophie? I just want to check something really quick. Come in. Open up a web browser for me. Do you have one open? It's open. You win. Right, type in standard error E-R-R-O-R, yeah, slope. You go to images, I want to see a formula. Go up, go back to web results. Yeah, you go to the first one. Down. What? Yeah, okay, that's fine. Yeah, there's a square root. Okay. Can I continue?
Yeah.
Yep. Right, so, continue? What was the formula we got for, what was the formula we got? We got y equals, what was the m?
Delta M.
No, the m.
1.
1.99 x plus 1.04, wasn't it? Yes?
That's the C, right?
That's the m and the c. Correct? Now let's imagine that this was the experiment with the circuit. What does the formula for the resistance equal? That would be 1 over the slope. So in this example it would be 1 over 1.99, which would equal 0.503. Correct? Yeah. Now, we want to calculate the uncertainty in my resistance. So if you look here, watch carefully, you can change this into R equals slope minus 1. And then you can use the formula I taught you in the last class. The uncertainty in R divided by R equals square root minus 1 uncertainty in slope over slope squared. So we get now uncertainty in R over 0.503 will equal, now what will happen, oh sorry, that minus 1, I'm sorry, that should be inside. This will all cancel, so we'll just get 0.6263 over 1.99. So So we get delta OR equals 0.16. So we have our answer. OR equals 0.503 plus or minus 0.16 ohms, as an example. Yeah. So this is what you need to do in lab report number 3 and lab report number 4, the type reports. Because in these reports you need to calculate the OR and you need to calculate the M, the resistance in electricity and the mass in newtons. And it's important that you put the error with your answer. I'll upload this video after school. But also, it's really good if you can keep your lab reports, because this is what you do in first year at university. You use Excel this way to make more useful calculations, like calculating this. And you can see it's not easy to calculate this. You have to do many steps. If we go back to Excel here, you have to first calculate, well, what's the first thing you need to calculate? First you have to calculate the slope and the intercept. And then what you calculate after that? The y hat and then the x hat. And then residual y, residual x. And then you can calculate the delta m, which is what you care about. But you're not even finished, because if you don't care about the m, if you care about 1 over m, then you have to use my formula to change or to calculate the uncertainty. Residual y, residual x, yeah. I'm going to upload this video. Yeah. Yeah? Yeah, this is average residual of y, average residual of x. Now, a word of warning before you go. What I'm showing you here, what I'm showing you here is a little bit simpler than what you do at university. So there's a couple of things I did which I feel at this level I'm happy to do, but at university maybe your teacher won't let you do. Okay, so one example would be, in my formula I use square root n, but I think the real formula has square root n minus 2. But I don't want you to use that formula because our n is so small. Also, I used something called average residual, whereas at university they'll use something called standard deviation. Maybe you've done this already. Standard deviation is nearly the same as average residual, but it's easier to calculate average residual. So in other words, I did a few things which makes the problem simpler, but it's not quite the same. There's a little difference, but I think this is a price worth paying. Okay, so this is what you need to do for the type reports as well. We'll close it.